a few words about myself. Similar to the first speaker, I think I'm also a product of the semiconductor design industry. I had a successful exit as a CTO and co-founder of a company in wireless semiconductor design. Transitioned to agriculture and supply chain technology, but porting a lot of the learnings I have from my previous company, especially technical learnings in the fields of semiconductors, electronics, and simulation technology. To Centaur, who is developing now a smart technology platform for traceable sustainability. So what drove me to start developing or solving this problem? I was lured into this project actually by my co-founder Vasilis, who is an agronomist and a very well-versed food scientist for many years. But what really kind of drove me to this is the statistics. First of all, let me know if you see my slides. I've started sharing slides, but I neglected to check with you guys if you can see them.
I see. You're good.
Okay, awesome. So that huge number there, $370 billion of value lost each year. And really, guys, this is not a developing world problem. It's not consumer waste we're dealing with here. It's farm level waste. It's product that is cultivated, harvested, and cannot find its way to the grain elevator, to the food processor, and eventually to the consumer. Due to a number of reasons, basically owed to the outmoded storage infrastructure we have. So crops fall prey to spoilage, mold, pests, a number of other risks, and we end up with this number. The other face of that coin is our lack of traceability in the supply chain. There's no such thing as a QR code that you can attach to a bulk quantity of grain. That lack of visibility, of course, is problematic. It kind of undermines the resilience of the supply chain and, of course, food safety. And last but not least, under the sustainability set of challenges, we really need to recoup 25% of the current level of waste just to make the calorie budget for 2050, feeding close to 10 billion people on the planet. And while we do that, we also need to kind of contain our GSG emissions out of agriculture. So that's really a tall order, and the numbers are daunting, but our approach to kind of solving those problems is by attacking post-harvest value loss through cognitive connected solutions. So we offer for the first time predictive quality analytics and prescriptive and automated interventions for making that supply chain more resilient and less lossy. That is a technology that's already kind of in the hands of some very, very noteworthy clients, like some top tier global grain companies, leading beverage company, a leading rice company, a leading Midwestern cooperative, and so on and so forth. And of course, the United States Department of Agriculture is using our sensors and our IoT platform. We really think that those companies, we feel that they're allies and kind of are working with us towards achieving that vision, which is delivering traceable quality for a sustainable food supply chain in the future. So, that's what we do. Now, how we do it is also quite interesting. As you said, as you mentioned, Kyle, there's definitely an IoT layer in our solution, and we're very proud about it. We cracked the fire problem first by developing the sensors that we need for crop storage and supply chain monitoring. We went as far as getting patents for those systems, but really at the heart of our system lies a digital twin approach. Like I said, I ported over some techniques from the semiconductor design space. So simulation and thermodynamic analysis is, a kind of a weapon of choice for designing high performance electronic systems. We kind of used and repurposed code essentially for simulating things like rain in storage and assessing the effects of microclimate and weather patterns on spoilage risks for crops that are stored and transported along the supply chain. So that infrastructure helps us deliver a number of use cases that are not possible with sensors and telemetry only. So for instance, we definitely do predictive spoilage monitoring. So using sensors, you can perhaps our competition is focused on discovering spoilage. Using the combination of a digital twin approach and sensors, you can predict spoilage, you can anticipate it, which means you can mitigate it. And then, of course, we're finding additional capabilities on top of that infrastructure. So our ability to detect the presence of insect pests like the number one root cause for spoilage in most parts of the world is insect activity. We're talking about storage or warehouse pests. So we're able to discover and understand their existence. And then we have some prescriptive methods for fighting them, namely in the form of applying CO2, like carbon dioxide treatments or phosphine treatments, which we have, our hardware is actually monitoring, and our digital twin approach is predicting the success of those methods. An additional use case, which is working very well for us in the current context, is predictive logistics, which is understanding the risks for spoilage for a bulk quantity of product moving along a barge or even a Panamax, like a bulk carrier across an ocean. So we can help our customers, we help our customers figure out the risks for spoilage in those 20, 30, 40-day transits. So doing all that, we do all that, of course, and we offer all that through a SaaS. And we've gone to certain lengths for delivering a system, which is, I mean, the underlying technology can be pretty daunting for somebody who's not very well versed in, say, thermodynamics or brain science. And, most of the time our customers are really focused on, marketing their grain, avoiding spoilage. So, we don't want to overwhelm them with the science. So we've abstracted everything. We're offering everything in the form of a mobile app. So this is a web app or a mobile app that you can use on any mobile device, and it kind of delivers insights to you, effortlessly. Basically, we help give our customers with the decision-making tools to drive decisions such as when to market their grain. So what is the use by date of my stored commodity? Something which they have not been possible to answer so far. But even making interventions like, hey, there's an increase in CO2 in my grain bin. What do I do? Can I use aeration? Can I use fumigation? Should I recirculate my grain and so on? So that's something, those micro decisions are being driven off of the analytics and the predictive insights, which flow to our customers' devices through the form of, obviously, push notifications. So, and this, last but not least, I mentioned energy and GSG emissions in my preamble. So, those grain bins or elevators that you see there in the background are huge consumers of energy. So you can all believe the amounts of energy and, of course, the corresponding emissions that go with maintaining, preserving grain in pristine condition for months on end. So we help we act as a smart thermostat, as a Nest thermostat, if you may, for grain stores. So we completely demystify the aeration management, which was an art, which was usually kind of mastered by very, very few grain experts. And this is a profession which is, of course, it's being phased out right now. So our customers are faced with workforce and talent challenges. So, an AI comes in and they can really delegate those decisions to our system now. What does the market look like? Of course, I led with showing you that we're losing 370 billion each year. So for all intents and purposes, that becomes the total opportunity or opportunity cost. For us, that's a TAM, that's a total available market. Granted, we cannot reverse all those all that waste and all those losses all at once, but we have identified through our expert advisors that at least 50 billion of that loss component is immediately recoverable through our technology. So that becomes our SAM, our serviceable market, if you may. And then focusing on how we can monetize on that, of course, helping the industry, helping the ecosystem save 50 billion in loss of opportunity. We can monetize for at least a portion of that. So 15 billion becomes our serviceable, obtainable market. And that is a number that's corroborated by independent analysis run by EY and other experts that using different approaches of quantify the opportunity that's generated through the introduction of broadband IoT technologies for making the supply chain, especially the grain supply chain, more efficient. Now, our business model, as I mentioned, is SaaS. We have different segments, and that I think is a key strength in our business plan is we don't serve just one segment, let's say on-farm. We serve the entire continuum of the supply chain. So on-farm, commercial storage, logistics, and food processing. There's a different fee model that applies slightly different. So in the case of on-farm and commercial storage, we serve those customers throughout the year. So there's a fee per stored ton per or bushel per year. And for logistics, we charge a percentage of the freight value. The LTV over CAC numbers, when our hardware layer is factored in, they look commensurate to the metrics of the LTV over CAC of any enterprise SaaS solution for that matter. So, and we can stretch that even further as we reduce, as we design for cost, and our, the cost of our hardware really becomes noise in the total cost of ownership of the solution. So we're already there. It's a very low cost and very scalable solution on the hardware side. Our sales KPIs, we have a pre-sale cycle of about 4 months. That's typically the average time it takes for a farmer or a commercial grain operator to kind of make a decision on adopting our solution. Our ACV range is very interesting because we start with small annual contracts for prolific farmers, as we call it, and then commercial contracts can scale up to 100,000 per year. And that, of course, that upper range of our ACV will gradually increase over time as we roll out more solutions. So, and this is our progress at a glance, and I think I'll stop with this slide. Being mindful of time. So we started with the seed round back in 2016, 2017. Everybody knows how tough hardware is, so we decided to crack that problem first. We developed the first version of our sensor to kind of target problems in the fumigation and pest control space, and then we layer our grain digital twin technology on top of it. We raised another round. That's all in convertible notes. And then we started adding more capabilities like volumetric analysis for grain bins, aeration autopilot. We've patented everything, all the key aspects of our methodology, either on the hardware side or software and analytics have been patented at this point. We grew our sales twofold in 2020 and another twofold in 2021, all within the pandemic. We hit break even earlier this year, and now we're raising a new round of financing to continue rolling out more use cases, especially in logistics, and of course, scaling our revenue. We're already in a couple of million kind of ARR, and we intend to grow that even more drastically going forward. So that's all about Centaur. My email is over there if anybody wants to get in touch with us, especially in the context of the new round that we're raising, which will be our Series A round. I'm happy to kind of interact with the other founders in this elite group of farm IoT founders and startup companies, or any investor that may be intrigued with what we're showing here today. Again, thank you, Kyle, for this opportunity. I'm open to any questions.
No, thank you. And fantastic. And I think this is, it's interesting. This is kind of why I included you more in the IoT category versus last month. There's a handful of companies within applications that are dedicated to, grain management, but that tends to be less focused on the actual, the IoT component and more focused on just the operations. But you're a really great example of how you've been able to put together a hardware solutions with really, I think, impressive predictive analytics and basically action items that farmers and users can take across both, again, not just within the grain elevators, but through the transportation process, through the different storage process. It's really impressive. And I don't even have any questions to add on top of it because I think you covered it very well. But I think what your system that you've built is, compared to what we've seen in the farm management section, is really great. Really great.
Thank you, Kyle. I appreciate that. That means a lot to us and being behind the product. Just a comment on predictive. There are two flavors and two schools of thought on predictive. One is, hey, I'm going to mine data through sensors to telemetry, and I'm going to run a lot of data analysis on it, meaning like regression and meaning those types of analytics. We don't think that kind of solves the problem for post-harvest quality management and spoilage prevention, simply because the solution space is so vast that we'll never have enough data. And of course, through climate change, the environment around you also changes and shifts. So the only kind of reasonable and sane way to do it is, we like to think our way, which is kind of fusing something which is a pre-computed model, comes with a simulation engine, can be executed in a massively parallel fashion on the cloud, and then training that model through sensors and IoT. So That's a quick comment on predictive and why we believe that, this is the winning approach for, especially for the problem that we're attacking with Centaur.
Fantastic. And real quick question: where is majority of your customer base today? Is it the United States?
Well, it's in North America, but we have about 40% of our customers are in North America. Another 30% are in the Europe, Middle East, and Africa region.
Fantastic. Well, Sotiris, I appreciate the time.